Now, in the last 2 years, a lot of people have been taking TA65, and that includes, I'm one of the people that's taken TA65. I've been taking the drug myself for 2 years. And a lot of these people that have been on for more than a year, finally we're offering some data. We've been getting our blood samples taken like every 3 to 6 months, tons of biomarker studies. You had to agree to all that in order to be able to purchase TA65. And after looking at a lot of the clients that have been on it for 1 year, definitely seeing some good things happening here. CD28 negative T cells. I'm not exactly certain what CD28 negative T cells are, except they're T cells, and they've been heavily published in the literature to be very correlated with aging. When you age, the older you get, the more CD28 negative cells you get. But the clients taking TA65 have shown a very statistically significant decrease in the CD28 negative T cells. Naive T cells have gone up, natural killer cells have gone down, blood pressure has gone down, skin elasticity has gone up. All these things correlated to what you'd expect if TA65 was actually helping reduce the symptoms of aging. So personally, I'm an ultra runner. I run 50, 100-mile races a lot. I've been doing this for 13 years. This is showing me running the Western States 100-mile race. This is running the Badwater 135-mile race in Death Valley. I've always been a back-of-the-pack runner. And in a lot of my races, I finished dead last. And, you know, I showed data where I showed that TA65 is causing telomerase to be produced inside of our cells. Well, from all that data, I would have expected that TA65 was very weak, couldn't possibly be doing anything that would improve anything like my running. But only 3 weeks after I got onto TA65, I started finding that my running performance improved dramatically. I started finding I was running past runners that beat me by hours every time. I was going like this, saying, I don't know what's going on. I ended up in that 3 weeks after taking TA65, I finished 9th place overall, first in my age group out of over 100 runners competing in the thing. And I couldn't figure out anything else except TA65 because nothing else has changed. And it's been like that ever since. I've been on TA65 for 2 years, and it's like, I don't want to go off it. I'm having such a great time with it. So I'm going to finish off with, does telomere shortening cause aging? And we don't know yet. We don't know. We can say it causes cellular aging, but nobody's ever been able to show that cellular aging causes organismal aging. And the only way we're ever going to show this is to develop a drug that does reverse telomere shortening, re-lengthen telomere shortening, at least stop the shortening, and show that it affects aging. TA65 might be such a nutraceutical, but it's going to take a few years to actually find that out. Is aging a disease? Again, we don't know if aging is a disease. The consensus among a lot of people is that it's not a disease, but Sierra Sciences and Geron Corporation are trying to cure aging, and if we succeed, then it says that aging is a disease. So, any questions?
I just don't understand in your graphic.
I can't hear you.
In the graphic where you show that the telomere is able to allow those building blocks to be put back on, I just don't understand genetically how is that possible if in fact that's now a shorter. Where's the code? As I remember from medical school, you need to have it to then to copy itself. So what's the blueprint? How do we know that what's going to be built is in fact appropriate?
Okay, maybe I don't understand the question, but the telomeres are made up of TTA-GGG. They don't encode anything. There's no genes there.
Okay.
And so you've got like 20,000 or more bases of just these T2AG3s. They're there just to stabilize the chromosomes, to protect the chromosomes from rearrangements. And when they get shortened, they really don't change anything in the gene sequence. And
okay.
In a given individual, is the telomere length the same in all cells, or do some?
It depends on the number of times a cell has divided. Okay, so when you're born, your cells, when you're a single cell embryo, you have a certain length. Well, as they start dividing, some are going to divide more than others. Those ones that divide more are going to have shorter telomeres. Plus, there's a statistical Poisson distribution of, because remember, whenever there's a short telomere, the long one still is around. Okay, so there's going to be a distribution, a random distribution. And right now, it's looking like it's really not the average telomere length that's important, it's the number of short telomeres you have.
I guess what I'm getting at is there any way to test in a given individual what their physiologic age is by measuring telomere length?
That happens every day right now. TA Sciences does that with all their clients. SpectraCell is a company that's going to start offering this test in June for $300 per patient.
Using what cells?
They're going to, well, they'll be using the blood cells, but they could do it with any cells if you can provide a way to provide it to them. There's been lots of papers published on looking at every cell from endothelial cells to a host of cells. I can't remember them all, but it's in all cases of dividing cells, telomeres get shorter. But when you look at different tissues, you do see different telomere lengths.
Thank you.
Any other questions?
When you're looking at increasing or allowing cells to continue to divide, what mechanism is in place when you're looking, because the thing that came to mind, how do we know that you're going to take this nutraceutical and not induce some kind of increased cell multiplication where you're going to induce a cancer?
Okay. So there is 85 to 95% of all cancers express telomerase. But telomerase has never been shown to cause cancer. In fact, telomerase has been shown to decrease the risk of cancer. Nobody's ever found a cell, a human cell, that expressed telomerase naturally that wasn't cancer. Cancer always has to come first. And it appears that one major way to cause cancer is to let the telomeres get short. And that might be one of the reasons why cancer is more prevalent in the elderly. But the rest of your question would be, it would be like any other drug or nutraceutical or anything like that. It has to go through some testing, and that's why we did things like DNA array analysis, because if it was going to cause cancer, we'd probably see some change there. And also, all the clients that are taking TA65, I'm not privy to all the data from there, but I do know that nobody has seen any adverse effects whatsoever.
So there haven't been any adverse effects? Is that what you said?
Right.
Okay, thank you.
I have a question. How do we get the TA65, or how do we learn about studies regarding this?
TA Sciences is here. They have a booth next door. But Jeff Life, he was here a few minutes ago. He is also somebody you can get TA65 from. But it is available. And but since I'm not, and there's Greta Blackburn walking in the back right now. She's somebody you can talk to about that. Okay.
One more question. Is there anything else that increases or vitamins, minerals that maybe work with TA65 or in conjunction with? Sometimes we're putting different things together would make this work a little bit better, or?
Nothing so far, because really all the metabolic pathways that occur inside of a cell really have nothing to do with the telomeres. The telomeres affect them as opposed to the other way around. I did say that we have now found 120 different drugs that turn on telomerase. They all have a little bit of toxicity, but we plan on doing synergy experiments, mixing them together to see if there's some way to improve the potency. And TA Sciences has agreed to let us do it with TA65 too. So
thanks.
Okay.
Stephen Coles from UCLA. As you were talking, I started thinking about the area of my hobby, which is the stem cell arena. Yeah. And there are two basic approaches now that are being discussed about how to create a large or amplified set of cells that would be autologous and not rejected if we infuse them back into the body. One is a method that uses embryonic stem cells, which is politically very controversial. Yeah. But the new method, discovered originally, I guess, in Japan, and now the work reproduced not only at Wisconsin, but at UCLA and many other labs, is called induced pluripotent stem cells. And a lot of people say that iPS cells are equivalent to embryonic stem cells. So all we need are adult cells from a skin biopsy. We don't need to do embryonic stem cells. That's what the religious conservatives are telling us. And it just occurred to me that if you derive an iPS cell from an adult cell, how would you have a telomere length that was equivalent to an embryonic cell? You wouldn't.
Right.
And if aging is related to telomere length, we may be giving cells which are based on iPS cells that are old instead of young. Does that make sense?
Yes, it's very likely that iPS cells will need a telomere extending drug in order to make them really effective. We are working with iPS cells at Sierra Sciences, and I don't know if you heard just last week or something, they've now shown that you don't have to put the 4 genes into the cells, you can actually just bathe them in the proteins. So that's going to make everybody, it's going to make it so we all can have our own human embryonic stem cells without sacrificing an embryo. Any other questions? All right, so I think it's the cocktail party.